Hello, and welcome to Mr. Jackson's physics class. Today, we're going to start talking about circuits. And today, we're going to start with a very simple type of circuit. It's called a series circuit. And a series circuit is pretty simple. So I'm going to draw one to make it very obvious. In a series circuit, of course, you always have to have a battery, which is our power supply. But in a series circuit, every resistor, whether it be a lamp or a stereo or a phone, anything you're putting electricity through, every resistor, the electricity must pass through. So as you send them through, so I'll do another one here. So I'm going to give you 3 resistors. And so this would be a 3 series resistor circuit. So the electricity leaving the positive terminal and coming back to the negative terminal must go through every single resistor. So that's a series circuit. So the current flowing through this has to go through every single one. So the current in a series circuit is actually going to be basically has to pass. So we'll say has to pass through every resistor. Okay? Very important. Has to pass through every resistor, and it is going and will be the same value everywhere. So that means that if you have a ammeter which measures current, if I put an ammeter here, or if I put it here, or here, or here, it would get the same results anywhere in the circuit. So it will be the same value everywhere. Okay? So that's very important. The resistors, however, will add up to a total resistance. So what does that mean? If I wanted to know the total restrictions that they all put together, R total will just be equal to R1 plus R2 plus R3, however many you have. So let's put a number on these. Let's say that this one is 10 ohms, this one is 10 ohms, and let's say this one is 10 ohms. Okay? So that means in this circuit that I've drawn, the total resistance here, R total, and the one above will be 30 ohms. So it's really simple. You just add them up. Okay? So they work together as a team. And so that's what's going to happen there. But the thing we need to remember that is that Ohm's law is the only equation you're ever going to need besides this little plus one here. Basically, we can find out everything we want with Ohm's law. What is Ohm's law? It's that equation I gave you earlier in the last chapter, V equals IR. But we need to put some sub-names on them. We're going to change V into V battery. And we're going to change I into circuit. So this is the current in the entire circuit. This is going to be the voltage of the battery. Let's give a voltage battery. Let's give it 30 volts today. Okay? And so then let's give you R, because they're multiplied together, will be R total we'll need. So if you use this equation, V equals IR, you can find out everything you need to know. So let's go back and actually calculate the current, which is the same value everywhere in the circuit. So how do I do that? Let's calculate the current. And all we need to do is we just simply need to go solve for I. So our battery is 30 volts. I is my unknown. And our total, which we found over here, is added them all up, is 30 ohms. So we bring this to the other side, so we end up with down below, so we have 30 divided by 30, so I equals 1 amp. Okay? So that means if I put an ammeter here, it will read 1 amp. If I put it here in the circuit, it will read 1 amp. It doesn't matter where I put it. Anywhere in the circuit, it'll read the same each time, okay? So that's pretty simple, okay? And that's what makes it really easy. So the next thing I want to ask you is, what about what's called a voltage drop? A voltage drop is a measurement or the measuring of the use of the battery by each resistor. And so each resistor, as the current passes through each resistor, the voltage here would be 30. But the voltage here will be less because as it passes through, some of the voltage is used up by this resistor. And then as it passes through, whatever was here is going to go down, so it's even smaller voltage. And then whatever goes through this last one will use up with the remaining one. And so they'll all use up all 30. So all three will use up the 30 volts. No matter what you do, every resistor, if I have one resistor, then it would use up all of them. So as you go from here and you go through all of them, to get to this point right here, there will be 0 volts. Okay, so these use up the voltage or the power of the battery. So we got to remember, how do we find voltage drop? Well, we're just going to use this Ohm's law. Okay, so we're going to go and let's say how do we do a voltage drop? Well, voltage drop is when you put a voltmeter around a resistor, and what a voltmeter does, it actually just measures the drop or the use of the battery by that particular resistor. So what is a voltage drop? It's the measuring of the use of the battery by each resistor. So we're just going to use Ohm's law. Okay, we're going to say V battery, but we're going to change this equation a little bit, and we're going to say I in the circuit. Remember, it's the same everywhere. That won't change. But what we're going to do here to figure out the voltage drop, we're going to change this to drop. Okay, so we'll do that right now. So what we're going to do is we're going to put drop here instead of battery. So this is called voltage drop. That's what I should have put there first. So take care of that. And then we're going to multiply it by R individual. So we don't want to deal with all total R's. We want to work with just this one. So it's the same equation, V equals IR, but this case, since we're looking at just the individual use by a voltmeter, okay, and so this is going to need a voltmeter. We're only going to use the information for the individual resistor we're over it, okay? So how do we do that right here? Well, here's how we would do it, okay? So we would go voltage drop that this would use. How much would this use up? I would put 1 amp, because that's what I have for this circuit, okay? So it would be 1 amp times by this resistor, 10 ohms, so it would use up 10 volts. So that would be the voltage drop for this one resistor, okay? And if we found all three of them, this would also be 10 volts, and that would be 10 volts, and 10 plus 10 plus 10 add up to the battery. So all resistors use up the entire battery voltage. And I want to show you how that works every single time. So the two equations you really need to know is just V equals IR, but one is battery, circuit, and total. The other one is drop, the voltage drop, which is going to be circuit times individual. So this means that all the voltage drops always add up to the battery voltage. Okay? So let's do another example, and let's use all these again. We're going to use these two main equations right here. Okay, from step number 4 and 6. But let's do 3 different resistors to change it up. Okay? So here's our battery. Let's say we have a 70 volt battery this time. And it goes through 3 resistors. And there are different resistors each time. And each different resistor has a different strength. And so what's weird is I'm going to say this one's 5 ohms. Let's say this one here is 10 ohms. And this one here is 20 ohms. Okay? And so we can tell this one, you think, well, gosh, this one is less resistance. So electricity just passes through this one really fast. So the current would be different on both sides. But it's not, and it won't be different, Because what happens when it gets to the 10, it slows down and then it backs up the electricity, so then it goes through both of these at the same speed. Then when it hits this one, it goes even slower because it's more resistance, so it backs up the electricity, so pretty soon it goes through all of them at the same speed. So the current never changes. So let's find, number one, the current in the entire circuit. Well, that's right here. But to do that, I need to first find the total resistance. And remember, that just adds them up. So R total is just simply 5 plus 10 plus 20. So it is 35 ohms. Real easy. So how do I find the circuit? We just go V equals IR, but we're going to use battery equals I circuit times by R total. And so basically we got to divide this. So the battery was 70 volts. Okay, so 70 volts divided by the total resistance of 35 ohms would be equal to my circuit of what it's going to be everywhere in the circuit. That's going to be 2 amps. Okay, so that's the speed of the electricity going through, or the flow of the electricity going through this circuit. Okay, well now, how much will the 5 volt use up? What is the drop or the usage of the battery? Okay, so if I want to find this one, we'll call this voltage drop 1 from the 5, or voltage 5 ohms. Remember, we just use V equals IR, but instead of using the total, we're going to only look at one individual resistor. So we'll go V drop number 1, okay, and it's going to simply be equal to, this is a V drop, a voltage drop, okay, and then maybe I put a D there for drop, but voltage drop 1, and so we're going to put it in a circuit, which I know is 2 amps, but I only want to use the individual resistor, so R individual, and so it's 5 ohms, and I get 10 volts. So this one, number 1, uses up 10 volts. And watch this. If I do another one, we'll call this one V2. This is another voltmeter. So then V2, these are drops, is going to be 2 amps because it's the same circuit, but this time it's times 10 ohms. So that's 20 volts. And then V3, which would be putting a voltmeter around this. And then that would be 2 amps because it's the same speed all the way through. This time, though, it's going to hit this resistor, which is 20 ohms. So I get 40 volts used up. So this one you're going to use up 10 volts. This will use up 20 volts, and this will use up 40 volts. And if you add them all up, you get 70 volts, which is the battery. So every time in a series circuit, every voltage drop finally uses up the entire battery every single time. Okay, so there's a quick overview. And so if you need to, of course, take snap right here, or your screen print, you can do that for the first section right there. And then you can do it for the second section. You can write that down in your notes, okay? Thank you very much for joining me. I appreciate it, and you have a great day. Blessings.